Hi, in this video we're going to be dealing with series and parallel, and it's part 6 in a series. So here we want to solve for the voltage on R7, we want to solve for the total current and the total resistance. I start off first by rewriting, I want to solve for this part right here, because I want to condense this whole circuit down until I can get the total resistance. So first thing I do is I work on these two, and in order to do that, I redraw them like this, where I just completely isolate them. And you could use one of three formulas to solve for these. You could use 1 over Rp, which is equal to 1 over R, 1 divided by R6 plus 1 divided by R7, or you can use this formula, which is R6 times R7 divided by R6 plus R7. Or you could use this formula, which is, it's a special one where if you have some resistors, and if the resistors have the same value, so this would be 500, this would be 500, the other ones, and any more resistors that you might have in this circuit, they would all have to have 500 ohms, but they'd all have to be parallel. Then you could use this. And in this one, you put the value of the common resistor, which would be 500 in this situation, and then you put down and you divide it by the number of resistors in parallel. Here, we have 2 resistors, so you put the 2 down there. And this is the formula I use to solve for. It's real simple. I plug it in here, and that's the value we get for RP1, the resistors in parallel, the first one. So, and then I take that resistor and I substitute it into the circuit. So I replaced R6 and R7 with RP1 right here. Now that I have this one, in order to combine it further, oh, my mouse froze. Okay. So combine it further, what we need to do is combine R5 and RP1. And those two are in series, so we can just straight add them. And I redrew them here the way we're working it. So it's R5 and RP1. They're both in series, so we can just add them. So the resistance in series 1, and this is what I'm calling RP5 and RP1. Well, the new one that I'm going to put in. So you just add those two together. It's 250 plus 250, which gives you 500. And then I'm going to take this new one, RS1, which is equal to 500 ohms, and I'm going to replace R5 and RP1 and substitute it in. So here is the new circuit. And now at this point, again, I want to combine these two, R4 and RS1. They're in parallel, so I'll use the parallel formula with it. And you can use either this formula, which is R4 times RS1 divided by R4 plus RS1, or you could use this formula, which is 1 over RP2, which is equal to 1 over R4 plus 1 over RS1. So you could use either one of these two. I just used this one because I thought it was a little bit simpler and straightforward. And once you put those values in, you're going to get 200 times 500 over 200 plus 500, which is going to give you this value and a total of 142.86 ohms. And that's what I put down for the value here. Now, once I get this, I'm going to substitute it back into our circuit. And so now we get this new resistor right here. And now we need to combine these two in order to further collapse the circuit down. And we're almost done at this point, but still have quite a few more steps. So here we have these two in series, and that's what I drew here. And this is the formula that you would use. Since they're in series, you can just add them straight up. So RS2 is going to be equal to 342 ohms, 342.86 ohms. So now I'm going to replace R3 and RP2 with RS2. And that's what I did here, and I substituted it in. So since now they're in parallel, now RS2 is in parallel with R2, well, again, I'm going to use the parallel formula. I'm just going to use this one. And I put them in. I just plug in the values, and then that gives you a value of 77.42 ohms for RP3, which is going to be the combination of here. Or this is what it's going to look like. When you substitute RP3 in, you're going to get this circuit. And at this point, now we can solve for the total resistance in the circuit. And since these are all in series, we can just add them up. See, the total resistance is equal to R1 plus RP3 plus R8. And you just plug in the values, and then you get the total resistance for the circuit. Now at this point, we could also solve for the total current. I also replaced the circuit here, but let's finish this part first. So the total current is equal to the voltage of the series of the supply divided by the total resistance. So the voltage of the supply is 100 volts, or the total voltage is 100 volts, divided by the total resistance, which we got 187.42 ohms, which will give you 0.534 amps. So now we know the total current and we know the total resistance. Now I'm running out of time, so I'm going to make another video where I show you how to go back and solve for, because we also wanted to solve for this guy. Where are you? Ah, yes, right here. We want to solve for the voltage across this resistor. So we're actually going to have to send the current, we're actually going to have to work backwards. Since we already know the current here, we're just going to send it into here. And we need to find out what the current coming through here is, and then we'll find the current going through there. And once you find what the current going through here is, at this point you'll be able to figure out what the voltage across this branch is. So we'll do that in the next video. So I hope you liked it. If you did, please like it. And good luck in your classes.